8.5 polar coordinates, or this is the second day on polar coordinates. Yesterday we learned about how to graph polar coordinates, and we were focusing on our r, which is the directed distance, and our theta, which is the angle starting from the positive x-axis. Today what we're going to do is focus on how do you convert between an equation that's in rectangular form, having x's and y's in it, to polar form, and how do you convert from polar form to rectangular form. And so this is the second half of 8.5, which is introducing polar coordinates. Next week, Monday, we're going to get into actually graphing the polar equations. So how do you convert equations? We're not converting points, we're converting equations. There are little tricks that you have to know in order to do that. And so I'm going to do 4 problems in the problem set. These are homework problems. And you'll see that if you can understand these little tricks, these sections aren't too bad in terms of doing your homework. It should go by pretty quickly. We're going to start with number 43 on page number 412, and you're going to see that it says r is equal to 6 sine theta. And the question is, convert that to rectangular form. In other words, take your r thetas and make them into xy's. If I can take all of my r thetas, get rid of them, replace them with xy's, then I'm done. I can't have an equation with any r thetas in it. And so we're going to turn to our equations that will help me convert. All of these 4 are going to be ones that will take my r thetas and turn them into x's and y's. So when I look at this equation, I'm going to see that it has to be exactly right in order to convert. Sine theta is not the same thing as r sine theta. So if I want to replace a y with r sine theta, I actually have to have an r in here, a 6r sine theta. So if I wanted r there, it would be multiplying the right side by r, which means that I really have to multiply both sides by r in order to use this equation or identity. So I'm going to multiply both sides by r, and when I do so, I get r squared equals 6r sine theta. At this point, this is exactly the same thing as this, so I can substitute in a y now for that, and my r squared is the same exact thing as this r squared, so I can substitute in x squared plus y squared, and I'm done. So in this one, it becomes x squared plus y squared equals 6y. Now, there are no more r's, there are no more thetas. I'm done. The question now is, do I have to solve for y? And the answer is no, because you're going to have y and y squareds, and to get y alone, you'd have to complete the square, and we're not going to get into that. So at that point, you would stop, and that leaves the answer like that. Then we're going to go to the next section, which is, or the next problem, which is going to be problem number 46. 46 says it's r squared equals 4 cosine 2 theta. Now, before I do this, I want to show you another way to do 43, just in case you're thinking about it a little bit differently. So I'm going to go off to the side here. So if you understood what I did there, that's fine. You don't have to think about this other method, but you can also do it a different way. You can say, I'm going to take this, and I'm going to say sine theta is equal to y over r. I don't like doing that because now all of a sudden you have a y with the r, and you want to get rid of your r and thetas, but you're mixing them together. I like keeping them separate. But if this makes sense to you, you could do that. So I can say sine theta is y over r. So in this one, I can say r is equal to 6 times y over r by using this equation instead of the one up above it. Then you could multiply both sides by r, and you could do that substitution here and get the same thing that you got over here. So there are a couple ways of thinking about it. My preference would probably be the way that I did it first. Let's go ahead and look at 46. And 46, we have a problem, and that problem is that we have a 2 theta. The 2 theta is not contained in any of these equations, so I have to break that down in terms of theta. There are 3 identities for the cosine 2 theta. It's a double angle. And so I'm going to choose the one that has cosines and sines in it, because I know that I can deal with a cosine squared and a sine squared. The problem, again, is it has to be identical to what I have over here on the right side. It has to have an r in it. I can't just deal with this. Now, I could if I did the blue equation, but by thinking about it the way I did the first method up here, is I have to put an r with that cosine squared. In fact, I can't just put an r with it. I have to put an r squared with it. Why do you have to put an r squared? Because you have an r cosine squared is not the same thing as r cosine. It has to be either an r squared cosine squared or just an r cosine. It'll make more sense when we go ahead and do it. So in other words, I don't want to just multiply by r because that's not enough. I have to actually multiply both sides by r squared. If I multiply by r squared, I think you'll see what happens in the work here. Because this is a subtraction, I can distribute the r squared through. And so it's going to be, I'm going to go ahead and convert that left side already. R squared is x squared plus y squared. And there are actually 2 of those, right? There's an r squared times r squared. So it's this times itself. So to write that in a little bit better form, I'm just going to square that because it's x squared plus y squared times x squared plus y squared. And then on the right side, you're going to have 4. I'm going to keep that out front, and I'm going to distribute that r squared through. So it's going to be r squared cosine squared, r squared sine squared. And now, hopefully you can see that the right side is the same thing as r cosine theta quantity squared, right? This is r cosine theta times r cosine theta, which is r squared cosine theta squared, right? The reason why I did this, that's just the power rule. The reason why I did this is because now this is exactly the way it is over here. And it has to be exact to substitute in. Same thing here, r sine theta quantity squared, because now it's exactly the way it is over here and I can substitute in. So at this point, we're ready to pretty much be done. This is going to be x squared plus y squared quantity squared equals 4 times, this is x now, so it's going to be x squared minus, and that's going to be my y squared. At that point, I'm done. You leave it like this. You don't have any r's and thetas left. You've converted to x's and y's, and you're finished. Both of these I multiplied by r, and the second one I did r squared. Now, for some reason, This section is harder than the one that follows it. The one that follows it is a little bit easier. It's just a direct substitution and you're done. This has a little bit more algebra involved with it. So let's go ahead and do two more problems with the next section. And the next section's directions are to convert from rectangular to polar, which means I want to go from x, y's to r thetas. Now, this is easy because it says y is equal to something and x is equal to something. You don't have to work with a more complicated variable. If I know x is equal to something, I can just substitute that in now. R cosine theta for x, R sine theta for y, and that's equal to 5, and you're done. That's a one-step substituting in. You now don't have any x's and y's, you just have r's and thetas. Similarly, on 54, again, these are much easier. X squared plus y squared equals 4x. You're looking at x squared plus y squared is just going to be r squared from this equation. And then my 4 times x, that's easy, 4 times r cosine x. Now there's one more step in 54 that you have to do, even though it's all in terms, whoops, this should be a theta. There's one more step you should do in this one besides substituting in, and that is to notice that if you could actually divide both sides by r because you're multiplying by r on both sides. Now, normally it's not a good idea to divide both sides by r or divide by any variable. The only time you can divide by a variable is if that variable does not equal 0. If it equals 0, you can't divide it out. And there were some algebraic problems that we had before where if you divided by a variable, you lost an answer because it could have equaled 0. But I know that r actually cannot equal 0 to make sense in polar form. Because if you think about your graphs in polar form, having a directed distance from that pole of 0 means you're staying right on that pole, right? If there's no distance, there's no distance. How are you going to write that, drawing a point? You can't. So that's why r can never equal 0. That's why you can divide both sides by r, since it can equal 0, and you can get r is equal to 4 cosine theta. That's all you're doing in this section is substituting using the 4 equations, making sure that everything is lined up exactly right for the substitution, and then and leaving it in that form. Don't worry about solving for any type of a variable.